In this session, I will show a very simple application programming using BPM. BPM is an acronym for Business Process Management. It is a kind of programming that is 50% of it. You'll be dragging icons because 50% of this is graphical or visual flow programming. And the other half of it, like if you double click on these icons, you can type real programs inside these icons. You can use the full power of Java, for example. But again, the other half of this is visual flow diagrams. The idea is that using a visual flow makes for a very transparent and understandable logic that can be examined by those that are even not programmers. So let us begin. The software that I will be using is IBM's Business Process Management solution. And this is WebSphere. Our programs will be deployed here. This serves as the container or the runtime of our programs. An analogy of this in the open source world would be Tomcat or Glassfish. There is also equivalent in Oracle's SOA solutions. I am now launching my IDE. And I will be creating my application here in this folder. Doing BPM programming is unlike all other programming development that I have experienced. I have used NetBeans, Visual Studio in the past, but doing programming in BPM is something that is very new to me when I started. It can be very disorienting, but know that the intention of BPM is to create a program that has a very transparent business flow, business diagram that can be visually inspected even by non-programmers. So the visual aspect is closely tied to the underlying program. Now I would like to connect my IDE to my container so that I can push my applications there. We can, for example, test the connectivity. And as much as possible, I disable automatic settings in my IDE. Everything should be manual, right? Just close this. I will now create a program that adds two numbers. New theme module. I will name it as test app module. And we are now led to the blank workspace, which is the canvas where we can drag the visual elements of our program. I will drag a process, and I can rename this or not, but I will just rename it desktop component. Now in IBM's BPM, a component must have an interface in order for us to add logic or do testing into the component. And before I do that, I would like to remind that the underlying technology that is driving this programming model is Java, SOAP, and XML. This trio is the engine that drives IBM's business process management development tools. I repeat, Java, XML, and the SOAP protocol. Now, with regards to Java, the component model that is used is the SCA, or Service Component Architecture. All right, let us begin. I would now add an interface by clicking to this one and click this icon, small icon here, add interface. Or you can do a right click and add an interface here. Either way, they achieve the same purpose. We add an interface into our component. Let us add now an interface. Let us name our interface as numeric or arithmetic interface. So we can accept this as the default. There's also a namespace, which also we can accept, but we can change that to any namespace that you want. Let us just accept the default. All right, proceed. Click the finish button. And this is the interface editor. An interface is just a holder of functions. So right now, we don't have any functions yet. It is add one. In the SOAP technology, there are two kinds of operations. The first one is request response operation, The second one is one-way operation. The difference between the two is obvious. The request and response expects a response. So when you invoke a call of this type, the call will block and wait for the response. On the other hand, if you invoke a call of this one-way operation, it is like a fire and forget. So you invoke a call and you continue what you're doing and never expects a response. It's a one-way operation. Well, let's use a two-way operation. So as add a function, add num. So in the inputs, since we need two numbers to add in this example, and obviously a single parameter of string cannot hold these two parameters, we instead declare a new structure or data type, and we will name this as add BO, BO being an acronym for business object or just a fancy term for XML. So in the SOAP world, in the simple object access protocol world, parameters are wrapped inside XML. Even the function name that you want to invoke remotely is in the XML itself, including the parameters. Maybe if you are confused with the SOAP technology, maybe you can try to have some basics of SOAP to understand the fundamentals. But let us continue. Now that we have defined a new data type, we add fields to this data type. And we name it as num1. The type is integer. And num2 as integer. Let us now click Save All. And that completes our input parameters containing two fields, num1 and num2. Let us go back to the interface window and the output. Let us change this to an integer. All right. So after defining an interface with one function, add num, and declare and properly defining the input parameters and the output parameters, as well as adding a data type business object containing the two fields to accommodate for the two numbers. Let us now go back to the assembly diagram. Do a right click to the component and click select generate export SCA binding. This we are now wiring to add code into our application. and then right click into this one, generate implementation. This is the look of our application. Our application starts here in this green circle and ends here. And in between are icons that we can add in the middle to describe programming intentions. In the receive part, it is the place where we receive the SOAP input params, and the reply part is that place where we write to the output params for the result. Now, in order to examine the SOAP parameters that was passed when calling the program, let us try to add an icon, a code snippet in between here, and this code snippet, if we click this and go to its properties, details tab, still allows us to do it visually, or now I will just choose in Java. Too much visualization is bad for your health. So this is a visual part and this is a programming part. Okay, so I will do system out, then I will say input 1 equals then input 1. If you recall, the this receive here receives the input parameters and we are printing it here. Save. Now our program is ready to be deployed. Go to this tab, servers, right click, and let us add let's build all, right? Then add here. We add this to the right area there. Finish. Now our application is ready for deployment. I mean, from our IDE, we'll push our application into the container here in our WebSphere. WebSphere will serve as the runtime for our application. I will now right-click and publish. There, and it is published. But how do we exercise or test our program? I will open now my command line, and I have a shortcut. If I stored the system out.log here, and if let us zero out the content of this to make sure that we get a clean output. It is 0 bytes, and I do a tail to that file, okay, our outputs will be written into that system out.log. So the system out.log that we route here will be written into that file. Now to exercise this hello world program that we created, a testing module is actually integrated in the BPM, in the IDE itself. We go back to the assembly diagram, right click, and test component. And we are here presented with a chance to input parameters payload to the function that we just created. This is num1 and num2, and we have this nice editor. We can type like maybe 3, and the second parameters like 4. So we supplied num1 and num2 with those values. This is just a testing simulation to our program, but in a real world, you will be invoking a SOAP request into your program. And then click here and press the continue button or play button. Let us choose this to be default so that we will not be asked for it in the second time. And so we're trying to invoke the test function now from our IDE. And as we can see here, we get an output from systemout.log successfully showing the content of the SOAP parameters that we just passed. I can change the number here. Like I can change it to, I can create a new one and make it as 7. And this one is 8. And again, test this function call, and we receive the parameters successfully. Let us continue. I will close this, or maybe I will save this as a new project. It's now here added in our editor. We can reuse that later on. Let us go back to this part here. Now I want to extract the values that we receive. I actually printed the whole object, but I want to have a finer granular access of the parameters. I will create a variable here like num1, and the type is an integer. Num2, the type is an integer. There. Then I would like to unwrap the SOAP that we receive here and The fields of that SOAP parameter, num1 and num2 respectively, we copy that to this newly declared variable that I added here. There is a BPM way to do that, and this is one of the tricks in this programming model. And that icon capable of doing dot assignment is this assigned icon. I will drag this now here. So there is an arrow going down. Right after receive, it invokes the assign, and after the assign, it invokes the snippet. You can imagine that a very big business program will blossom into a big diagram containing like a flowchart with arrows that's like this. And when you click its block, still zooming in into smaller drawings inside. Very crazy kind of programming at first. So I will now click this assign icon. And here I will click select from. And since I receive the input one SOAP, I will expand this. And from the fields of that SOAP XML that I receive as an input param, I will click num1 and I will assign it to the temporary variables that we just created, num1. Then add, then do it again, extract num2 from the SOAP business object and assign it to num2 temporary variable. That's it. And save. I will now go to the snippet. Then I can declare a variable here and sum. And I have now access to the parameters of our function call, num1 plus num2. And I will change this to sum equals sum. Then output 1 equals sum. There, let us introduce a syntax error for illustrative purposes. Let's say that I forgot this colon, semicolon. I save, then I do a build all. You have to go to the problems tab to see the errors, and we have one errors. And if I right click there, it will lead you to the line with having the error. Add the semicolon, then build all, go back to our problems tab, and everything is clean. Time to publish. Again, publishing is pushing our code, our componentized code inside into here in WebSphere application server. So let us now published. Still in publishing state, as we can see here, started and publishing. It is very important that we only do a test run of our code if the state is started, comma, synchronized, like this. In the event that there is a change in our code, it will advise you to republish. We should only do a test run from our IDE if the state is started and synchronized, which is the case right now. So everything is in sync. Going back to the assembly diagram and opening our terminal, since I saved my test cases before, I will just open that and click this test module. Okay, we can rerun this test case. So we are rerunning this case with 3 and 4 as the input parameter. And let us see the output. The sum is 7. How about the other test case, where the parameters are 7 and 8? Let us rerun this case, and the sum is 15. And at the same time, the output got written into the output params in our interface here. So the output also got written here. The task of marshalling is already handled automatically for us. So any client that invokes this SOAP component, our application now can be consumed by SOAP clients. Going back, for example, you might decide to do an if else check. This is not really much related here, but maybe it will drive the point that doing BPM programming is a different kind of activity than the traditional programming that most of us are familiar with. So we drag this choice icon. So let's say I will drag this choice icon here. So in between the assignment and the snippet, there is a choice, and the case is here. I will add another case. I will right click to the choice and add a case, and then add an otherwise. So this is now how it looks like. If else, else if, then else. So prepare yourself to do programming like this in BPM. Again, I would like to reiterate that the purpose of BPM is for managers and billionaires who are not programmers. They want to see the flow of the business. They want to see what happened to the program. Because they could not understand Java, they can only understand pictures and graphics. This is the reason that BPM is invented. It's basically for these people. We need to please them because they are the one who spent billions of dollars to develop the applications, and they have the rights to see how the program behaves and is designed. If, for example, your program is written in JavaScript, who can verify what happens when the JavaScript writes into the database? Who can prove that nothing was changed or where the values are written on what tables in the database? Because there is no picture, the program often becomes a secret minefield of information that only the programmer understands, and it is very hard to communicate the logic of the application to non-programmers. And as you can see here, I will now implement case. Let's say that this, I will add print statements under each. I'll add a snippet here. I will also add under this case and so on. Then I will put a statement here saying that both numbers are equal. Then I will add a case, create a new condition. I will say that num1 is equal to num2 as the condition. If that is true, then it will follow this arrow here. Again, this is crazy at first, but you get used to it. Now, if this condition is true, it will flow here and the rest of the conditions here are ignored. So it will not propagate to the right side. So only one of these is executed, just like a if else statement. Now, if this is not true, then it will check this second condition. Let us add if num1 is maybe less than num2, let us, instead of doing it like that, we can actually choose Java as the expression. Say like this. So how about that if I say that if num1 modulo num2 equals 0. So I'm saying that if num1 is perfectly divisible by num2, if the modulo is 0, then to simplify, I'll just rename this as the flag and return the flag. So again, this second condition is carried on if this flag is true, and so snippet 2 is printed, and it's now again print a message here. Modulo. Otherwise, if none of the case and the case 1 are true or satisfied, if none of these two cases are satisfied, it goes to the otherwise. condition without any further check and prints this one. So we're doing here an if else check of the parameters that are being passed, specifying conditions. If this condition is satisfied, like num1 is equal to num2, then this snippet gets printed and never execute the other of the cases. However, if this one is not satisfied, take note that the precedence here is left to right. If this is not satisfied, then it goes to the next one here. If there is a modulo relationship between the two parameters, then this snippet is printed and it ignores the otherwise case or condition. Finally, if none of the two cases or the two conditions are satisfied, then the otherwise column here is executed, which if you look at the arrow, print the snippet 3, hi there. And then, as usual, it goes to our existing code as before, which adds the two numbers. So to summarize, we just added a switch statement in the middle that prints different messages based on the input parameters. So show you what the visual programming in BPM looks like. Well, as you can see here, we're just typing snippets of Java, but it is also possible to use the full power of Java programming. You can import different packages in Java, use classes of Java and object orientation, and so on. That is just for another topic. I will now compile and check for the problem solved. If there are errors, there is none. Again, build all. All right. Go to the servers tab, and you can see here that the state is started, republish. Since we added a new changes to our code, our state is now stale. So we need to republish to sync our IDE and the application container. Right click and publish. Publishing is just pushing our application to our runtime container, not running yet, just pushing it there. And as soon as the state is started, synchronized, then that's a good time to exercise our application. We go back again to our test window. Here, it is integrated, and click this one. The parameters are 3 and 4. I would think that none of the two conditions are satisfied, so this would go to the otherwise case and prints hi there. Rerun, and so it prints hi there, and our sum is 7. Okay, since we will create a new test condition here and carefully design our specify our parameters, like if they are equal 9 and 9. Okay, create another one, and like 14 and 7. This is the modulo. 14 divided by 7 is 0, and it has a modulo relationship. Okay, I will now invoke this case, 9 and 9. This will fall into our leftmost case, this one, and it should print both numbers are equal. I will invoke this case, and we have the expected output. Both numbers are equal. I will go to the other test case, 14 and 7. This will fall into the, since this condition is not satisfied, num1 is not equal to num2, then it the the direction is left to right. It will check this one, and the modulo flag is true because num1 divided by num2 as modulo is perfectly divisible, and this will be true. This case will be satisfied and the arrow is followed. It will print snippet 2 and it will print this message. Invoke this test case, and as expected, it prints the modulo message. For the rest of the conditions wherein the first and the second cases are not satisfied, for example, in this input, 3 and 4, or yep, or 7 and 8, we'll rerun this. It will go to the otherwise condition and press hi there again for the second time. And in our test window, we can also see that the invoke was started and the return was generated, thus completing the call. If you recall, the interface that we created is our request response interface. So our response SOAP object was generated and marshaled back to the caller. The caller will unwrap this and find the result there, the sum 7. So this is the very basic of BPM using IBM's BPM development tools. This is the Integration Designer, or IDE, and this is the application container, which is an enhanced web sphere, a web sphere with added BPM plugins. And the folder, let us try to go there, desktop. So in summary, it created these 5 folders. Let us try to see if there are Java files here. And there are none because we are doing the pure graphical programming model here. It is also possible to add Java code, in which case we will find a Java file that will be generated here. For example, I can drag this For example, I can drag a Java entity there and maybe name it as helper component. And if I double click, um, we will create a package like com IBM that I do it because I like to do it. Okay, I do it, or I will do it. Okay, and so we are lead into a Java class file with auto-generated template. Save this, and if we examine again the file system, we can see this Java implementation. All right, and it also created the folder structures com IBM. I do it because this is a prerequisite when we create the package. These are just folder hierarchy, if you recall. That's it. And I hope this tutorial gave you a whirlwind overview of what BPM is all about. You're going to need this so that you will not get caught and surprised during your first month of joining a team who might be using this programming tool. Even if you are an expert programmer, I tell you, during the first month of using this, it will make your head spin. Thank you, and that's all for now.